Well, hello there, ladies and gents. Let's rock and roll. You know how you did yesterday. These questions are uber similar to yesterday's. So, and Tuesdays and Mondays. Are you getting more intelligent? Are you understanding this more so as the days progress? If that answer is no, then you need to change the way that you're approaching math or you're wasting your time. Hopefully that answer is, yeah, actually, I'm starting to understand this. That would be phenomenal. Look at your notes. You already know how you scored on this. Try to really focus on the ones you get wrong. That's how you learn. Start with the first one. We have 8. I lied. We do not have 8, Mr. Stahl. We have 2,785. And we are taking groups of 8. So the question is, how many 8s are in 2,785? Well, you take 8. You can't go into 2, but you can go into 27. But how many times? Well, 8 times 3 is 24. 8, 16, 24, and then 4 groups of 8 would be too many. So after you take away your 3 groups, what's left over? Well, after you take away 3 groups of 8, there's 3 left over. Bring down the 8. How many 8s are in 38? 5. Just kidding. 5 groups of 8 would be 40. If you're not good with multiplication, just count by 8s. 1, 2, 3, 4, 5, 6, 7, 8. That's one group. 9, 10, 11, 12, 13, 14, 15, 16, 2 groups. 17, 18, 19, 24, 32, too many. So 4 groups would be 32. There's 6 left over. Bring down the 5. How many 8s are in 65? 8 times 8 is 64. Shut your mouth and shut the door. Someone told me that once, something like that at least. Now there's 1 left over. This is where we might differ. You were always taught, just put an R, like there's a remainder of 1. But is that mathematically savvy? What does I have 1 left over mean? If you're making groups of 8, it's simple. You guys know fractions. There's 1 left over, but you need to have 8 total for a group. So there's 348 groups and 1/8 of a group. You could always put your remainder as your numerator and the divisor as your denominator. Let's go to B. Ooh, we're multiplying by decimals, though. Whenever you multiply by decimals, remember, kind of ignore the decimals and treat them as whole numbers. If the decimal's not there, it would be a beautiful number 0.85, which is pronounced 85. And then there's no decimal on the right anyway, so it's 82 times 85. Y'all know me. You know my favorite method is lattice. I always like to start with this corner, but it doesn't matter which corner you start with. 8 times 5 is 40. 5 times 2 is 10. 8 times 8 is 64. And 8 times 2 is 16. 0 falls down. 6 plus 1 plus 0 is 7. 4 plus 4 plus 1 is 9. And then the 6 falls down. Now we just got to deal with that decimal dough. So here we go. We have this decimal right here. How many total digits are after the decimal? 2. What about over here? There is no decimal. So 2 total digits are after the decimal. So we have to make sure there's 2 total digits after the decimal here. Even though this is a 0, it's still one of the digits from the problem, 85 times 82, so it counts. So therefore, the answer is 69 7/100ths, or 69 7/10. Either way works. This is a harder problem here. We have 3. We're losing 2. And then we're going to take that and we're going to multiply it by 10 divided by 6. Kind of, except for the order was different than I said. First thing that we always do is whatever's in the parentheses. There's two ways to do this: throw it in the house or slice it. Whenever I have small numbers, I like slicing it because I like fractions. 10/6 is easy for me to see. I know it takes 6/6 to make a whole. I got 10 of them, so there's a 6/6 trapped in here. Ah, get me out. It's also known as one whole. What's left after you get the 6/6 out? 4. 4 what? 4/6. Can we simplify it? Sure can, but we'll just do that later. Now, I'm going to rewrite things. I'm not going to try to do this first, because if I do, I'm going to say 3 minus 2 is 1, and that would not be right. So instead, I'm going to rewrite it. 3 minus 2 times 1 and 4, 6. Once I do that, I realize, oh, I have to multiply first. I don't remember how to multiply fractions. Oh, yeah, I do. You have to multiply numerator by numerator, denominator by denominator. Remember, it fits in a beautiful little crab's eyes named Mr. Krabs. Aye, aye, SpongeBob. 2 is 2 wholes. 2 wholes looks like this. 2 wholes. Can I put a denominator? Sure, I can. I just put a 1 under it. And then this is a little bit different. It's bigger than 1 whole, so I have to turn it into an improper fraction. How do I do that? 6 times 1 plus 4. 6, 7, 8, 9, 10. 10, 6. Now I multiply across. 2. And some of us are like, Mr. Stahl, don't multiply yet, dude. Look, you have a top number and a bottom number that can be reduced by 2. Yes, you are right. And if you know that, then you want to reduce first. It makes life easier. But if you do not know that, then just multiply across. 2 times 10 is 20. 6 times 1 is 6. How many sixths are trapped in 20? Well, 6, 12, 18. There's 3 of them. That took 18. There's still 19, 20, 6. So now we have a new problem. This is represented by 3 and 2 sixths. So I'm going to rewrite that down here. 3 and 2 sixths. And then I'm going to have 3, and I messed up. I messed up because this is negative. It's negative. You can't have 3 and take away from it 3 and 2 6, Mr. Stahl. So it's actually negative 2 6, also known as negative 1/3, because it's not only smaller than 1, it's negative. Or it's not only smaller than 0, but it's negative. So I'll explain that during the live session. All I got to say about that is, my bad. It happens with algebra sometimes when you make up your own problems. All right. Let's jump into this one right here. We got one irregular looking figure. Remember, you got to make sure it's 2 normal figures or 2 regular. How do you do that? I'd cut it there. Mr. Stahl, I wouldn't cut it there, man. I'd cut it right here. That's fine too. Either way, you have 2 rectangles. This rectangle is 5 by question mark, but question mark can be figured out because if this whole thing's 15, but this part is equal to this part, this is 8. And 8 plus something equals 15. It's not 8 plus 8, that'd be 16. It's 8 plus 7. 7 times 5 is 35. And then 8 times 12, 8 times 10 is 80, 8 times 2 is 16, so 8 times 12 is 96. And then I just want to add those 2 together, 96 and 35. But it's feet, and it's 2-dimensional because we're looking for area. 131 square feet. I feel as though I should pause the video and go and listen to you guys complain that I messed up on the bell work because it's, or the challenge question, because it's probably already there. But you're right, I'm wrong. I did mess up. I'm hoping that was the only one I messed up on. All right, but I'm not going to do that. All right, for the record, I went and fixed it. I can't stand mistakes that I make, and I make a lot of them. All right, we're going to jump ship now. We are going to learn about our new unit, but before we learn about our new unit, ladies and gentlemen, I want to introduce you to a very, very honorable man. This guy right here, he's a king. He's not just a king. He might be the best, greatest, most wonderful mathematical king that's ever been around. I mean, he's infamous. His name, King Henry. Can't talk about King Henry without talking about the tragedy that is tied with King Henry. I think I could talk about it now. King Henry was a phenomenal man, but he had a weakness. And his weakness is that he had a love. He had an absolute love for, well, it ended up being the death of him. He loved chocolate milk. Loved it. Couldn't get enough of it. Literally couldn't stop drinking it until it was just too much for him. However, ladies and gentlemen, King Henry did leave us with something. He left us with a saying. And this saying helps us with measurement, helps us with conversion. Check it out. King Henry died by drinking chocolate milk. He did. And it helps us with mathematics. Now, what you're going to see and understand that in the metric system, we want to measure all different sorts of things, right? We want to measure weight, we want to measure distance, we want to measure volume. And what's beautiful about the metric system is it gives us the ability to measure all those different things. And I'm going to explain further during our live session, but you just need to understand that King Henry died by drinking chocolate milk. Okay. Now, today we are going to measure distance. Now, in America, we measure distance with miles. We could then say, oh, how tall are you? Well, I'm 1/1000th of a mile tall. No, we don't measure things that are as tall as us in miles. We measure like how far Traverse City is from Michigan in miles. But when it comes down to trying to figure out what piece you need to fix your furnace, you can't measure it in miles. So there's got to be different things you use in different situations. That is why we have miles, and we have feet, and we have inches. But in the metric system, it's much cleaner. It's much easier. So we're not learning about the American system, I'll call it. We're going to learn about the metric system. Now, with the metric system, everything is powers of 10. So the B stands for base. So with the metric system, we're using meters, right? And 1 meter is right in the center of the system. But if you want to measure something smaller, you go down. And it takes 10 of these to make 1 of these. What's it called? Well, let me start all the way at the top, okay? The kilometers. It's kind of like miles. They use those if they want to measure like really big things or big distance. They're called kilo, right? And it takes 1,000 of these meters to make 1 kilometer or kilometer. And then it takes 100 meters to make a hectometer, okay? So, and then it takes only 10 meters to make a decameter. and then you have your base, your meter. But if you want to measure smaller things, then you have a decimeter. It takes 10 decimeters to make 1 meter. You have a centimeter. It takes 100 centimeters to make a meter. And you have a millimeter, which are those like centipede leg looking like things when you look at a ruler. So this will make more sense as I continue to explain it. I understand right now it might not make all the sense in the world, but this is the metric system, okay? And if we're measuring distance, this is what we're going to use. Now, what's beautiful about the metric system is that all you have to do is move a decimal when you convert. Let me show you. So let's convert meters to millimeters, okay? So remember, meters is right here, and we're going to turn it into millimeters. So let's say we measure something, and it's 15 meters. And we want to say, okay, that's cool, that's 15 meters, but I want to know how many millimeters it is. Well, there's a cheat. The cheat is you write down King Henry died, and then I always put a little box for buy, drinking, chocolate, milk. And the way that I do it is I always put King Henry died in capitals, because remember, those are longer units. And then I put DCM in lowercase because they're smaller units. And as you go this way, obviously each one gets way, way smaller. And then I put whatever the base is. Since we're measuring length, we put meters. So watch how easy this is. Now, first thing you have to understand is this M, not this M. This M is millimeters. So this M is actually, right now, mm. So what we're going to do is we're going to go from meters to millimeters. And remember, these are teeny tiny, okay? And these are a lot bigger. How much bigger? Well, let me remind you yet again. One of these, one of these equals 10 of these. And one of these equals 100 of these. And 1 meter equals 1,000 little tiny millimeters. Now, if you go the other way, it takes 10 meters to make a decameter. So a 1 meter is only worth 1/10 of a decameter. And 1 meter is only worth 1/100th of a hectometer. And 1 meter is only 1/1000th of a kilometer. Okay, so this kind of just helps you remember. But in all reality, in order to convert, all you have to say to yourself is King Henry died by drinking chocolate milk. Make sure you put whatever you're measuring. So right now we're measuring meters. And then we can convert like this. This is my start. This is my finish. And I'm going to go right once, twice, 3 times, right? So I'm going to start here, and I'm going to go here. I go right 3 times. Now, I go up to 15. I put 15. 15 has an invisible decimal here, and guess what I'm going to do? I'm going to push it right 3 times. So I know that it takes 15,000 millimeters to make 15 meters. Huh? You like that? No, Mr. Stahl, I'm super confused. Let's try another one. Let me start fresh so you can see how easy it is. Oh, they want me to convert. Okay. King Henry died by drinking chocolate milk. What am I converting? Oh, I'm converting meters. So I'm going to put meters here, and I'm going to make sure my brain knows that's a millimeter because it's an M just like the meters. Now I'm going to go from 2,040 millimeters to meters. So I'm going to go from meters, or I'm sorry, I'm going to go from millimeters to meters. I just need the directions. So I'm going to start here and move here. I'm going to go left once, twice, 3 times. Those are my directions, left 3 times. I'm going to write down what I have right now. And I'm going to now take the decimal. Well, it's a whole number, so it has an invisible decimal there. I'm going to move it left 3 times. Once, twice, 3 times. Bada bing, bada boom. 2,040 millimeters is equal to 2.040 meters. Okay. And then let's try this one. If you feel crazy, why don't you pause the video and try that one yourself? If you don't feel crazy, well, I'll do it for you. King Henry died by drinking chocolate milk. Once again, it looks like we're using the metric system with meters. So I'm going to put M here, and I'm going to put M here so I know. And really, everything gets an M attached to it. Kilometers, kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters. Everything actually, and I don't have to do this. I just want your brain to know everything actually gets an M to it. Except for the M, because the M is meters. So what are we doing here? We're going from CM to M. Here's CM. Here's M. I'm going to go left once, twice. My directions are left twice. I'm going to write my 877. And then I'm going to move it left twice. Today, in math, when I say, hey, did you watch the video? You're going to say, yes, mustard. Mustard is the secret word today. Yellow mustard. Remember, if you are confused, there's nothing wrong with being confused. I will explain this more and more and more and more as we go through it. So good job watching. I'll see you at 10:30.